Welcome everyone to the DSL session. We have got a packed session with 6 talks for you. Our first talk, unfortunately, is by a pair of authors whose travel plans were canceled at the last minute. So we have one remote talk at this OOPSLA, and it is happening right now. So, Yossi, please take it away.
Okay, I'm going to start the presentation now. Okay, so welcome everyone. I'm afraid we are in a very awkward situation in which I, for some reason, cannot hear the audience, but the audience is supposedly hearing me. So what I will be doing is I will be going back and forth as I present from the chat to the main presentation. Okay, so you can pretend that this is a recording. And the topic of my presentation is Fluent APIs in functional languages. This work was done by Roth and Yossi, and notice the order of the authors is not alphabetical, and this is not randomly. This is by decision. We both come from the Department of Computer Science at the Technion. That's a photograph of the building. And let me introduce to you Captain Ori Roth. Captain Ori Roth is my PhD student, and he is a full-time Army officer. And I haven't seen him or heard from him ever since the war started. You can see some of the fireworks we have here. And I tried myself to make it to Lisbon. Some of the flights were canceled. So let me try to deliver the presentation to the best of my ability in this awkward situation that we are in. Okay, since Ori is not here, I'm going to try to suggest a different title to our work. Our work should be advertised as pick any functional language you like, and we will show you how to embed in it any DSL you like. But by showing you, I mean that you have to go into the details, into the deep logics and hints to the lambda calculus that are beyond implementation. But we don't have a tool to offer you, not the level that you can use right away. But in principle, this work allows you to take any domain-specific language and embed it in your favorite functional language. Okay, if you want to view this presentation, this contribution in view of languages, this could be described as how F# is better than C#. Well, are there any F# people who are F# enthusiastics in the audience? Please respond in the chat. I'm sharing the wrong screen, I'm sorry. Wow. Okay, am I on the right screen now? Is it okay now? Okay, I'll just flip through if it's okay. I'll stick to edit mode, that's good enough. Don't worry about that. Okay, can I continue my presentation? So quickly, the paper is done by Ori Roth and myself, and this is Ori Roth. I suggested that the alternative title of our work would be the extension of your favorite programming language, functional programming language, to embed your favorite DSL. And I was discussing the issue of how F# is better than C#. And then I went to check whether the people in the audience who are enthusiastic of of F#, because I'm not an F# expert, and I would appreciate the help. If anyone in the audience is an F# enthusiast, please raise their hand or feel free to interrupt. Okay, so going back to the presentation. What we found in this research is that F#, and F# is just an example, is a challenge for embedding languages in it. We thought that it was impossible, and let me show you what we found. Okay, so let's start with this example, which basically summarizes the contribution of our work. So suppose you have a web page, and this is the text of the web page, and you want to take this web page and assign it as is into some value or some variable in your favorite programming language. In our example, the favorite programming language was standard ML. And the embedding was done in this way. We needed this little bit of syntax here and this little bit of syntax here to allow the embedding. And other than that, we used operator overloading and the syntax of standard ML as it is to embed in it our HTML code. So this is the actual code as it's been written, and if you take it and you feed it to your favorite standard ML compiler, then it would run, it would compile if and only if the syntax here is correct. Of course, for this to happen, you'd have to load the library that we generated manually. But then if you do that, you'd have something which is quite fantastic. You'd have here the property that the type checking of standard ML would allow you to check the structure of this HTML document, meaning that it begins with HTML and ends with HTML, and body is within HTML. And furthermore, it allows you, or the type checker standard.ml would check that in each and every row there are exactly the same number of columns. And this is quite remarkable because this is not context-free language. Okay, now let me remind you of link. This is a very successful example of DSL embedding. And here's an example how this is being done in C#. In C# you can write something like that. This is the code that you write, and you write the code. You write this C# code, and then you can begin writing something that looks like SQL. It's a variant of SQL, and there is a little bit of C# magic that translates that what you've written here into C# code. And the whole magic here ends with a semicolon. Okay, so that means that link does something very similar to what we do. Okay, few words about link. The whole language is C#. The embedded DSL is SQL. It's well integrated into C#. It is so well embedded into C# that you can extend and change the implementation of link if you wanted to. The implementation, as I said, is by language extension, and SQL support is built in. Other DSLs, it's not clear how much you can do. But the fundamental property of link is that it relies into translation into C# code. And this C# code is written in what is known as the Fluent API. And this Fluent API relies on its turn on a property called overloading, language property. Okay, so having seen what's going on in link, let's discuss the story of query expressions in F#. So as I said in the beginning of my presentation, F# is advertised as being better than C#. And the promotion of F# requires the embedding of DSLs. Specifically, the people who are prophets, advocates of F# really want to have this F# to have something similar to link. However, due to the fact that F# is a functional language, they cannot do that, and they had to do an extension which is very different from the extension of link to C# in order to be able to embed DSL code in F#. However, in principle, you could have used our technique. I haven't actually tested the code. I'm not an F# practitioner. You could have done the same thing that's being done in SML in F#, because you rely on two things: the ability to invent your own operators, so you can invent your own syntax, and the type system, which makes it possible to embed whatever programming language that you wanted in F#. So presumably, F# code with the appropriate library written in the same fashion as described in our paper would be able to embed not only our HTML example, but also SQL or variant of SQL that you do. Okay, so what was the problem in taking the C# approach and implementing it in F#? The thing is the following. The magic here that we see in embedding SQL code within C# is realized by what is called Fluent API. So there's a little magic translates this to this, and from that point, this point on, C# carries on with its own compilation process. So, and the syntax here is Fluent API. You start with an object, you apply a method to it, then you apply another method, and here, when you iterate over the collection, you again apply a method, and you can apply more methods, etc. So, Fluent API fundamentally depends on the fact that you can interpret the same identifier in different meanings. So, for example, if you had a file object with a simple Fluent API, then you would want to allow sequences such as open, read, close, but you wouldn't want to allow close on a file that hasn't been opened, and you won't allow open to be applied twice before the file being closed to that, which means that open is sometimes okay and sometimes is not okay, and it depends on the type of the receiver object. In order to do Fluent API, you have to rely on overload. So I see that I'm running out of time, so let me proceed quickly. Fluent programming languages rely on Hindley-Milner type systems. Hindley-Milner type systems do not admit overloading. This is what makes it possible to have everything clean, elegant, and still very expressive. If you had allowed overloading, this wouldn't have worked. So we tried doing that, and we found, to our surprise, the following result. Not only that we can do in Hindley-Milner type system more the same languages that we can do in using overloading and procedural language, object-oriented languages separately. We can do more than this. We can do more than context-free language. And the trick here is simple. This was the difficulty. The difficulty was that you cannot. There is not much you can do with the Hindley-Milner type system. There is no kind of computation you can do that. You have types, and you can build types of types, and you can check whether the type matches, the type of the argument matches the type of the parameter. So that's it. You cannot do any computation. This reminds us of the lambda calculus. In lambda calculus, the pure lambda calculus, there's nothing that you can do. You can just have functions that call other functions. So the trick that worked was to use Church Boolean.
Okay, I'm sorry to stop this short, but we need to move on to the
Well,
next talk in the
Boolean.
session. So let's
Church
thank
Boolean
our
is very
speaker.
simple.